here we have 3 registers, and each of these they have a data that we want to push to our stack in order. So again, here is our registers. You can see we have the stack pointer, and we have 3 registers that we want to save their values. On this side, we have the memory, and these are the addresses, and it would continue in this way. Also note that this address is smaller than this one. So here we have a B, here we have a C. So that means this is the larger address. So these are our high address, and in this direction, we are going to our smaller addresses. Also, this stack pointer is having this address. So the content of the stack pointer is this, which is pointing to this location. And as we discussed before, the location that the stack pointer is pointing to is the top of the stack. That means the current element, or the last element that is there in the stack. So anything less than that address, so in this direction, anything after this, it's basically empty. So you can think of it as empty, which basically is either is like some garbage value or is uninitialized, but basically you can write data over there. Anything that is larger than this, we said that it's our other items, and it's our stack. So how do we push these values into our stack? So we said there are 2 different ways, and I said I prefer one of them, that basically we don't need to move the stack pointer every time we are writing an item, and instead we want to move it just one time. So what we are doing here, we are using save word first of all, because we are storing from register to memory. So that's the direction that we have. And for that, we are using save word, store word. So the first element that we're going to write is have an offset of -4 from the current stack pointer. So if you look at this location, the offset of -4 from this location is going to be the next element here that it's empty. And because you are using a negative offset. The next item that we have, we are using the offset of -8. So that would be here. And likewise, the next one is -12. So that would be if you start from here. So that's 4, 8, 12. So this is where the third item going to land. And in each of them, of course, we have these 3 registers. So 11, 12, 13, and each of them are in the offset that is calculated from here. And lastly, we are going to increment, or actually decrease this, to update the pointer to the top of the stack. So we're gonna see this. So after we are doing this, I'm gonna go line by line. So first thing here that you can see, all the memory addresses is calculated. So it's basically -4, -4, -4, and -4. So that's the memory address that we have. After running this first line, so saving register 11, so this 13 here, to -4 from our stack pointer. So currently our stack pointer is at C0, which is here, and -4 of that is here. So that's the first thing, that if we run this line, basically we're going to copy this data over this area, this location. The next line of code is going to take register 12, which is this data, and do an offset of -8. So the stack pointer is still here, it's still pointing to this location, but this time we are using offset of -8. And that means we are going to write the content of register 12, which is this hex number 23, to offset of -8 from this location. So that is where it's going to be saved. And after that, we are doing offset of minus 12. So that would be here. So that's 4, 8, 12. So it's going to be here. And we are doing register 13, which is the hex number 0x33. So register 13 going to be copied to this location. And like the last step that they have to do is to update our stack pointer. So our stack pointer should always point at or to the top of the stack. That means this is the item that is at the top of the stack. We just added it and it should point there. So how do we update that? It's already pointed here. And all we need to do is to move it basically 3 location. Each of them is 4, so that's 12. So it's gonna go minus 12 and that's gonna be here. Also, you can look at the last offset that you had. So you had minus 12 and that would be basically top of your stack, your last item on your stack. And you can do the same minus 12 there and it's gonna basically be the same location. So that is how you do basically push multiple items in your stack without actually updating your stack pointer in every step.